Hello everyone, today we will discuss the topic Rebound Hammer Test. So, following are the IS codes used for reference. So, IS 13311 Part 2 1992, that is non-destructive testing of concrete, methods of test. IS 516 Part 5 Section 4 2020, that is Part 5 indicates the non-destructive testing of concrete and Section 4 indicates Rebound Hammer Test. IS 8900 1978, that is criteria for rejection of outlying observations. The rebound hammer method could be used for first assessing the likely compressive strength of concrete with the help of correlation between rebound index and compressive strength. That is, compressive strength of concrete depends on many factors such as water cement ratio, cement strength, quality of concrete material, quality control during production of concrete, etc. Second, assessing the uniformity of concrete. The uniformity means for each batch, concrete properties must be consistently same. Third is assessing the quality of concrete. And last is assessing the quality of one element of concrete in relation to the another. Now, when to do this test? First criteria is if 28 days cube strength failed. In that case, we have to do this test. Second, if curing is not done properly by the contractor, then the client will take the objection and he will suggest to take the rebound hammer test. And third is if in the mixed design the design strength is not achieved, in that case we are performing this particular type of test. So this figure indicates the different parts of rebound hammer starting from the left end, that is concrete surface on which the test will be performed. Next is plunger, impact spring, hammer mass, locking button, hammer guide, release catch, window and scale where rebound number will indicate, rider on the guide rod, impact spring. These are the parts of the rebound hammer. Now, principle of the test. When the plunger of rebound hammer is pressed against the surface of the concrete, the spring controlled mass rebounds. The extent of such rebound depends upon the surface hardness of the concrete. The surface hardness and therefore the rebound is taken to be related to the compressive strength of the concrete. The rebound is read off along a graduated scale and is designated as rebound number or rebound index. The apparatus used for this test. Rebound hammer number is a measure of surface hardness up to depth of 30 mm. This is the rebound hammer. It consists of a spring control mass that slides on a plunger within a tubular housing. The impact energy required for rebound hammers for different applications is given below. For normal weight concrete, the impact energy required is 2.25 Newton meter. For lightweight concrete and impact sensitive parts of concrete, the rebound energy, that is impact energy required for rebound hammer is 0.75 Newton meter. For mass concrete, that is in road, airfield pavements and hydraulic structures like dams, the impact energy required for rebound hammer is 13 Newton meter. Procedure. First, for testing, smooth, clean and dry surface is to be selected. If rough surface is present, this should be rubbed off with a grinding wheel or stone, that is abrasive stone. Rough surface resulting from incomplete compaction, loss of grout. Loss of grout means that is caused by leakage at construction or formwork joints. Ensuring that formwork joints are grout tight reduces the risk of its occurrence. Spalled or tooled surface do not give reliable result and should be avoided. Now, spalled surface is usually caused by water damage, freeze-thaw cycles or chemical reactions. Spalling of concrete can be expose the steel reinforcement and lead to further deterioration. Now photo A shows grout loss and photo B and C shows spalling in concrete. That is, reinforcement are exposed. So while conducting the test, select minimum 150 mm diameter area of the structure for the test. The point of impact should be at least 20 mm to 50 mm away from any edge or shape of discontinuity. The distance between impact points should be 20 mm minimum and up to 25 mm. Next is you have to draw the grid or boxes. Take minimum 6 readings and maximum up to 20 readings for a single point. Generally we are taking 10 points for accuracy. Now the following figure shows the grid box system. In this figure, total 25 grid boxes are drawn and the impact points which are selected are 10. From bottom horizontal line up to the impact point, you can see minimum 20 mm distance we have to take according to IS code. It should vary between 20 to 50 mm also. That is, from edge of the member or shape of discontinuity, the minimum distance should be 20 mm. The distance between two impact points must be minimum 20 mm. And for the area of impact, the minimum diameter must be 150 mm. Procedure for conducting this test. For taking a measurement, the rebound hammer should be held at right angles to the surface of the concrete member. The test can thus be conducted horizontally on vertical surfaces or vertical upward or downwards on horizontal surfaces. If the situation demands, the rebound hammer can be held at intermediate angles also, that is minus 45 degree, plus 45 degree. But in each case, the rebound number will be different for the same concrete. Rebound hammer test is conducted around all the points of observation on all accessible faces of the structural element. Concrete surfaces are thoroughly cleaned before taking any measurement. Around each point of observation, minimum 6 readings of rebound indices are taken. Average of these readings after deleting the outlier as per IS 8900 1978 becomes the rebound index for the point of observation. In a given set of data, whenever a large number of observations, that is say more than 25%, are found to be outlying, it may be desirable to discard the entire data according to IS 8900 1978. Now, angle of rebound hammer. The following figure shows, the figure A shows the rebound hammer, that is plunger, is held horizontally. So the angle we are considering 0 degree. In second figure, that is B figure, you can see the rebound hammer is held vertically upward. So we will consider the angle minus 90 degree. And in third figure, that is C figure, the rebound hammer is held pointing in vertical downward direction. That is, we are considering the plus 90 degree angle. The following graph shows the correlation between rebound number, that is rebound indices, and compressive strength. In this graph, you can see the 3 slanting lines are shown. The uppermost slanting line indicates the rebound hammer is held vertically downward direction. The middle line indicates the rebound hammer is placed horizontally, and the bottom line indicates the rebound hammer is pointed towards upward direction. So, while calculating the compressive strength according to the position of pointing direction of rebound hammer, we have to select the particular lines, and from that we have to find out the compressive strength. The following table shows the rebound number and quality of concrete. If rebound number, that is rebound indices, are greater than 40, in that case the quality of concrete is very good. it is good layer concrete. If it is 30 to 40, it is good layer concrete. If 20 to 30, it is fair. Less than 20, it is poor concrete. And if rebound number is 0, that is delaminated. Now we will see one example how to calculate the rebound index or rebound number. So, which I have taken at the site. First is 46, second is 38, 44, 46, 54, 44, 43, 46, 48 and 50. These are the 3 rebound number readings. So average of these readings are, that is addition of this all the readings divided by 10. Total number of readings are 10. So you will get 46.1. So approximately that value is 46. So we have to set the upper limit, maximum limit and minimum limit. So you can see in the observed reading, apart from 46, how many readings are there? So first is 38, second is 44, next is 54, 44, 43, 48 and 50. There are 7 readings which are different from 46. So while setting the maximum limit, average of the readings, that is 46, plus the number of readings which are different from 46, that is 7. So you will get 53. Minimum limit, that is 46 minus different readings, number of different readings, that is 7. You will get 39. So maximum limit is 53 and minimum limit is 39. The values which are lesser than 39 and greater than 53, that we have to discard first. So from observed reading, the value which is less than 39 is 38, and the value which are greater than 53, there are no readings. So the discarded value is indicated in red color. So discarding that value, you have to again take the average reading, that is average modified. So summation of all the readings excluding 38 divided by total number of reading, that is 9, you will get 46.7. So rebound index or rebound number, you will get approximately equal to 47. Now influence of test conditions. The rebound number are influenced by a number of factors. First is influence of type of cement, that is concrete made with high alumina cement can give strength 100% higher than that with the ordinary Portland cement. Concrete made with super sulfated cement can give 50% lower strength than that with ordinary Portland cement. Second is influence of type of aggregate. Different types of aggregate used in concrete gives different correlation between compressive strength and rebound number. Normal aggregates such as gravel and crushed rock aggregate give similar correlation, but concrete made with lightweight aggregates require special calibration. Next is influence of surface condition and moisture content of concrete. The rebound hammer method is suitable only for close texture concrete. Open texture concrete, typically of machinery block, honeycomb concrete or no fines concrete, are unsuitable for this test. Influence of curing and age of concrete. The relationship between hardness and strength varies as a function of time. Variation in initial rate of hardening, subsequent curing and conditions of exposure also influence the relationship. Separate calibration curves are required for different curing regimes, but the effect of age can be generally ignored for concrete between 3 days and 3 months old. Now, influence of carbonation of concrete surface, that is carbon dioxide reacts with calcium hydroxide, that is CO2 penetrates in the concrete, which reduces the alkalinity of this concrete and carbonates the concrete. The pH value get reduced to 8.3 and protective layer get destroyed and steel is exposed to the corrosion. Carbonated concrete gives an overestimated of strength, which in extreme cases can be up to 50%. It is possible to establish correction factor by removing the carbonated layers and testing the concrete with the rebound hammer on the uncarbonated concrete. Now, interpretation of results. The rebound hammer method provides a convenient and rapid indication of the compressive strength of concrete by means of establishing a suitable correlation between the rebound index and compressive strength of concrete. The rebound number increases as the strength increases, but it is also affected by number of parameters which we have explained before. It is also pointed out that rebound indices are indicative of compressive strength of concrete to a limited depth from the surface. If the concrete in a particular member has internal microcracking, flaws or heterogeneity across the cross section, rebound hammer indices will not indicate the same. As such, the estimation of the strength of concrete by rebound hammer method cannot be held to be very accurate, and probably accuracy of prediction of concrete strength in a structure is plus minus 25%. Thank you.